The worthless cook who built a flamethrower from kitchen parts saved 200 Marines at 547 hours on the 21st of February, 1945. Corporal Miguel Rodriguez crouched behind a destroyed ammo crate on Iwo Jima, watching Japanese muzzle flashes wink from the bunker 40 yards ahead. 26 years old, kitchen duty for 8 months. Zero combat experience. The concrete pillbox had been spitting machine gun fire for 3 hours, pinning down 2 full companies of Marines on the black volcanic beach. Rodriguez carried an M1 Garand and 64 rounds of .30-06 ammunition. The Japanese had a Type 92 heavy machine gun, 2-inch steel, reinforced walls, and enough stored ammunition to hold that position for weeks. Rodriguez had not volunteered for this. He had volunteered to cook. Mess Sergeant Carlos Gutierrez had told him to stay in the field kitchen 200 yards behind the lines and keep the coffee hot. But the Japanese pillbox commanded the only approach to Rodriguez's mobile kitchen. Every supply run drew fire. Every Marine seeking hot food became a target. Rodriguez had counted 14 wounded men crawling past his position in the last hour. The corpsmen were running out of morphine. The Marines called Rodriguez worthless because he burned breakfast twice in his first week. They called him useless because he served cold beans during the Marshall Islands campaign. What they didn't know was that Rodriguez had worked in his uncle's auto repair shop in El Paso for 6 years before the war. He understood fuel systems, pressure ratios, and controlled combustion. He had also helped his father install restaurant equipment in 3 commercial kitchens. He knew propane flow rates and safety protocols. The Marine saw a clumsy cook. Rodriguez saw himself as a mechanic who happened to work with food. The Japanese machine gun opened fire again. Tracers snapped overhead. Rodriguez pressed himself deeper into the sand and coral debris. The Type 92 fired 450 rounds per M in Ute with a maximum effective range of 800 yards. The bunker was positioned to create overlapping fields of fire with 2 adjacent positions. Standard Japanese defensive doctrine. The Marines had already tried direct assault twice. Both attacks failed with heavy casualties. The company commander was calling for naval gunfire support, but that would take 40 minutes to coordinate. The Japanese knew this. They were using the time to reinforce their positions and redistribute ammunition. Rodriguez studied the bunker through his rifle scope. The structure was built into natural rock formation with only the firing aperture visible. The concrete walls were at least 2 feet thick. A 75mm recoilless rifle might penetrate, but the nearest one was back at the beach. Bazookas had proven ineffective against similar positions. The Marines needed something that could project intense heat and flame directly through the firing port. Something that could force the defenders to abandon their positions or die where they stood. Rodriguez crawled backward, 20 yards to where his mobile kitchen sat abandoned behind a coral ridge. The kitchen was a standard Marine Corps field unit mounted on a trailer chassis. 2 large propane tanks, 40 gallons each, fed a cooking surface capable of preparing meals for 200 men. Rodriguez had been complaining about the fuel pressure regulators for weeks. They were inconsistent, causing uneven heating. Mess Sergeant Gutierrez had told him to stop being perfectionist and work with the equipment he had. Now Rodriguez wondered if those pressure irregularities could be weaponized. The propane tanks contained liquid petroleum gas under 250 pounds of pressure per square inch. The standard regulator reduced this to 11 psi for cooking applications. Rodriguez disconnected the regulator assembly and examined the main fuel line. It was 3/4-inch steel tubing designed to handle full tank pressure. He traced the line from the tanks to the cooking surface and calculated flow rates. Without the pressure reduction, each tank could deliver approximately 8 cubic feet of propane per M in Ute through the main line. That was enough fuel to create a flame projection system with a range of 30 to 40 feet. Rodriguez needed 3 components: a fuel delivery system, an ignition source, and a pressure chamber to create sustained flame projection. The propane tanks provided fuel under pressure. The kitchen trailer had a compressed air system for operating pneumatic can openers and mixing equipment. The air compressor generated 150 psi, enough to create additional pressure differential for increased range. Rodriguez disconnected the air lines and began fabricating connections between the propane system and compressed air system. The most difficult challenge was creating a mixing chamber where propane and compressed air could combine before ignition. Rodriguez found a large steel mixing bowl, 12 inches in diameter, that had been damaged by shrapnel during the landing. The bowl had several holes punched through it, but the basic structure was intact. He sealed the holes with metal patches cut from tin cans and food service equipment. Using wire and clamps from kitchen repair supplies, he created a crude pressure chamber with input valves for both propane and compressed air. The ignition system required more improvisation. Rodriguez needed something that could create sustained flame, not just a spark. He found a bundle of kitchen matches and several bottles of cooking alcohol. Soaking rags in alcohol would provide initial ignition, but he needed something more reliable for sustained operation. He removed the pilot light assembly from one of the stove burners. The pilot light used a simple flame jet that burned continuously as long as fuel was supplied. Rodriguez adapted this system to work with his improvised pressure chamber. The delivery system posed the greatest technical challenge. Rodriguez needed a way to project burning fuel mixture in a controlled stream over distances of 30 to 40 feet. Standard kitchen equipment was not designed for this application. He considered using sections of exhaust pipe from destroyed vehicles, but the diameter was too large. Then he remembered the pressurized fire suppression system installed in the kitchen trailer. The system used narrow steel tubing to deliver fire suppressant to equipment compartments. Rodriguez disconnected this tubing and tested its pressure capacity. The steel tubing could handle 300 psi without deformation, well above his operational requirements. Rodriguez worked for 90 minutes while machine gun fire continued to rake the Marine positions ahead. He could hear wounded men calling for corpsmen. Several Marines had attempted to flank the bunker position, but Japanese rifle fire from adjacent positions forced them back. The situation was deteriorating. If the Marines could not neutralize the machine gun nest soon, they would have to withdraw from this section of beach. That would mean abandoning wounded men who could not be evacuated under fire. By 0800 hours, Rodriguez had assembled his improvised flamethrower system. 2 propane tanks connected to a mixing chamber through pressure regulators salvaged from pneumatic equipment. Compressed air system providing additional pressure boost. Ignition system using modified pilot light assembly fed by alcohol. Soaked combustion chamber delivery system using 8 feet of pressurized steel tubing with makeshift nozzle created from kitchen funnel. Total weight of complete system, 67 pounds. Estimated fuel capacity, 45 seconds of continuous operation or 200 individual bursts of 1/4 second each. Rodriguez tested the ignition system first. The pilot light functioned correctly, creating sustained flame as long as alcohol and air mixture were supplied. The flame burned blue. White with a temperature Rodriguez estimated at approximately 1200 degrees Fahrenheit. He tested the pressure chamber by introducing small amounts of propane through the primary fuel line. The mixture ignited and burned cleanly without backfire or explosion. The combustion chamber maintained consistent pressure as long as fuel flow remained steady. He tested the delivery system by introducing compressed air only, no fuel. The system generated strong, directed airflow through the steel tubing with enough velocity to project lightweight debris 35 feet from the nozzle. When he combined compressed air with unignited propane, the mixture emerged as a visible vapor stream that dissipated rapidly in the morning breeze. Everything functioned as designed. Rodriguez had created a functional flamethrower using kitchen equipment and field expedients. The critical test came when Rodriguez combined all system components simultaneously. He opened the propane valve to minimum flow rate, activated the compressed air boost, and triggered the pilot light ignition. A 6-foot stream of burning fuel erupted from the nozzle with enough force to maintain coherent flame projection even in the wind. The flame burned orange, yellow with black smoke, indicating incomplete combustion due to improper fuel. Air mixing ratios. Rodriguez adjusted the air pressure and achieved cleaner burning with reduced smoke signature. The improvised weapon consumed propane at a rate of approximately 2 cubic feet per minute during continuous operation. With Bosch cubic feet of fuel available in the 2 tanks, Rodriguez calculated maximum operating time of 45 utes if used in short bursts, or 45 econs of continuous firing. The compressed air system could maintain pressure for approximately 45 utes of intermittent use before requiring manual recharging with the hand pump, built into the kitchen trailer's pneumatic system. Rodriguez conducted range and accuracy tests using scrap metal targets placed at measured distances. Maximum effective range appeared to be 100 feet under calm wind conditions. Beyond that distance, the flame stream dispersed too widely to maintain sufficient heat density for effective target engagement. Accuracy was poor compared to firearms, but adequate for engaging large stationary targets like bunker apertures. The weapon functioned most effectively at ranges between Arsha and Censure feet. The question was whether it would work in combat conditions against trained enemy soldiers who would be shooting back. Rodriguez had no training in flamethrower tactics. He had never operated any weapon more complex than his ME Garand. The Marines who carried standard MEA portable flamethrowers received 2 weeks of specialized instruction in target selection, range estimation, approach techniques, and safety procedures. Military flamethrower doctrine emphasized concealment during approach, rapid engagement from close range, and immediate withdrawal after firing to avoid enemy counterfire. Operators worked in teams with infantry, providing security and suppressing enemy positions. Most flamethrower attacks were coordinated with artillery preparation and smoke screens to mask the operator's movement. Rodriguez would have none of these advantages. He would have to learn tactical employment principles in the next few minutes or die trying. The psychological factor was equally important. Standard military flamethrowers had established reputations on both sides. American forces knew their capabilities and limitations. Japanese defenders knew what to expect and had developed countermeasures. Rodriguez's improvised system represented an unknown quantity that might work precisely because it fell outside established tactical patterns. The Japanese would not expect flamethrower attacks using non-JAN standard equipment operated by support personnel. However, this psychological advantage would disappear after the first use. If Rodriguez succeeded in neutralizing the bunker, Japanese forces would quickly adapt their defensive measures to counter similar improvised weapons. The element of surprise was a single JAN-use asset that could not be repeated. This increased the pressure on Rodriguez to achieve decisive results with his first and probably only opportunity to employ the weapon effectively. The technical risks were substantial. Rodriguez had constructed his flamethrower using components never intended for weapons applications. The pressure vessel had not been tested under combat stress. The fuel lines might fail if damaged by shrapnel or small arms fire. The ignition system could malfunction at the critical moment. Any technical failure during combat would leave Rodriguez exposed to enemy fire, while carrying highly flammable fuel supplies. If the propane tanks were hit by enemy bullets, the explosion would kill Rodriguez and any Marines nearby. Rodriguez understood these risks, but considered them acceptable compared to the certain casualties that would result from prolonged fighting to reduce the Japanese bunker through conventional methods. His improvised weapon might fail, but it represented the only realistic chance of neutralizing the position quickly enough to save the Marines pinned down under machine gun fire. The tactical situation demanded desperate measures, and Rodriguez possessed the technical skills to attempt them. Rodriguez studied the Japanese bunker position. The firing aperture was approximately 6 inches wide by 6 inches high. Range from his current position to target 60 yards. His improvised system had an estimated maximum effective range of 6 feet, approximately 6 yards. He would need to advance to within 10 yards to ensure adequate fuel density at the target. That meant crossing 10 feet of open ground under direct machine gun fire. Even if he survived the approach, he would only have one chance to use his weapon effectively before drawing concentrated fire from multiple positions. Rodriguez decided to wait for the next Marine assault and use it as cover for his approach. He could hear NCOs organizing another attack. 2 squads would advance from the left flank, while a 3rd squad provided suppressing fire from the right. The attack would begin in approximately 10 minutes. Rodriguez shouldered his improvised flamethrower system and began moving toward the forward positions. Sergeant William Hayes, squad leader for 1st Squad, 2nd Platoon, saw Rodriguez approaching with his strange contraption and assumed the cook had finally lost his mind from combat stress. Hayes had seen this before during prolonged campaigns. Men with non-Zan combat assignments sometimes broke under the psychological pressure of living in constant danger without the outlet of fighting back. Hayes was about to order Rodriguez back to the kitchen when he noticed the technical sophistication of the equipment. This was not the work of someone having a mental breakdown. This was engineering. Rodriguez explained his plan in 3 sentences. Hayes studied the improvised flamethrower and recognized its potential effectiveness. The device might work against the bunker's firing aperture if Rodriguez could get close enough. Hayes modified his attack plan. 1st Squad would advance from the right to draw Japanese attention. 2nd Squad would provide covering fire from current positions. Rodriguez would approach from the left during the confusion and attempt to neutralize the machine gun with his improvised weapon. If Rodriguez failed, the assault would proceed as originally planned. At Imbasisi Saushire hours, Hayes gave the signal. 1st Squad rose from their positions and advanced toward the bunker, firing continuously. The Japanese machine gun immediately swung to engage them. Muzzle flashes strobed from the bunker aperture. Marines dove for cover as bullets chewed up the coral around them. Rodriguez began his approach from the left, crawling on his belly through loose sand and rock debris. The flamethrower components scraped against the ground, making noise that could attract attention. But the sound of gunfire masked any noise from his movement. Rodriguez covered 10 feet in 4 minutes. The Japanese had not detected his approach. The machine gun continued to engage Marines advancing from the right. Rodriguez estimated his range to the bunker at 10 feet. Close enough for effective engagement, he positioned himself behind a coral outcropping that provided partial protection from rifle fire from adjacent positions. The bunker's firing aperture was clearly visible. Rodriguez could see the machine gun barrel protruding through the opening, and the shadows of at least 2 men operating the weapon. Rodriguez activated his ignition system first. The pilot light caught immediately, creating a small blue flame in the combustion chamber. The alcohol-jan-soaked rag assembly burned steadily, providing reliable ignition source for the main fuel mixture. He opened the propane valve slowly, allowing gas to flow into the mixing chamber at approximately 1 cubic foot per minute. The flame grew larger and more intense, changing color from blue to orange as the fuel-jan-air ratio shifted toward fuel-jan-rich combustion. He opened the compressed air valve to increase pressure and mixture density. The compressed air system was operating at Yalcillion psi, well within safe parameters for the improvised pressure chamber. The flame became white and hot at the core with orange outer edges and began to roar audibly as fuel flow increased. The sound was similar to a blowtorch but louder and more intense. Rodriguez knew the noise would attract attention, but he was committed to the attack. Rodriguez aimed a delivery nozzle at the bunker aperture, compensating for the estimated Shu-Jan-foot height difference between his position and the target. He opened the main fuel valve fully, directing maximum flow through the delivery system. A stream of burning propane and compressed air mixture erupted from the nozzle and struck the concrete wall 6 inches below the firing aperture. The initial flame stream measured approximately 8 feet in length, with a core temperature Rodriguez estimated at over 18 degrees Fahrenheit. The flame clung to the concrete surface and spread upward, but most of the fuel burned harmlessly against the exterior wall without entering the bunker interior. Rodriguez realized his aim point was too low. He adjusted the nozzle angle upward approximately 10 degrees and triggered another burst. This time, the flame stream passed directly through the firing aperture and disappeared into the bunker interior. The Japanese machine gun stopped firing immediately, cutting off mid-gen burst. Rodriguez could not see inside the bunker, but he could hear screaming and the sound of equipment being thrown around. The burning fuel mixture had ignited wooden ammunition boxes, personal equipment, and probably clothing inside the confined space. The temperature inside the bunker would have risen to over 10 degrees Fahrenheit within seconds. The smoke from burning materials would have made breathing impossible. Anyone inside would have 2 choices: evacuate immediately or die from heat and smoke inhalation. Rodriguez maintained steady flame projection through the aperture for 10 seconds, ensuring complete saturation of the bunker interior with burning fuel. He then shut off the main fuel valve to conserve remaining propane, while keeping the pilot light active for rapid re-engagement if necessary. Smoke continued to pour from the bunker aperture, indicating sustained fires inside. The position appeared to be neutralized, but Rodriguez waited to confirm before exposing himself further. The Japanese machine gun did not resume firing after 30 seconds of silence. Rodriguez triggered another 3-second flame burst to ensure the position remained untenable and to ignite any ammunition supplies that might not have caught fire during the initial attack. The second burst created visible secondary explosions inside the bunker as small arms ammunition and grenades cooked off from the intense heat. Still no return fire from the position. Rodriguez signaled to Sergeant Hayes that the bunker was neutralized by raising his rifle above his head and waving it back and forth 3 times. Hayes acknowledged the signal and immediately ordered his Marines to advance and secure the position. First Squad rose from their concealment positions and sprinted toward the smoking bunker, maintaining tactical spacing and covering each other's movement in case of resistance from adjacent Japanese positions. First Squad reached the bunker without encountering resistance from the neutralized position, but Japanese rifle fire from the remaining 2 bunkers forced the Marines to take cover behind the destroyed machine gun nest. Hayes peered through the firing aperture and saw 2 Japanese soldiers lying motionless on the floor. Their uniforms and equipment were still smoldering from the flamethrower attack. The Type 92 machine gun was undamaged structurally, but too hot to touch. Wooden ammunition boxes continued to burn, filling the interior space with smoke. Hayes ordered 2 Marines to clear the bunker interior and recover any useful intelligence materials, while the rest of his squad prepared to assault the next position. The Marines used entrenching tools to drag the bodies outside, then ventilated the space to reduce smoke concentration. They found maps, radio codes, and ammunition storage records that would prove valuable for intelligence analysis. More importantly, they had eliminated the key defensive position that was preventing further advance. Rodriguez's successful attack had immediate tactical consequences beyond neutralizing a single bunker. The machine gun position had been part of a mutually supporting network of 3 fortified positions. With the center position eliminated, the remaining 2 bunkers lost their overlapping fields of fire. Marines could now advance between the positions and attack them individually. The entire Japanese defensive line began to collapse as Marines exploited the gap created by Rodriguez's improvised flamethrower. Within 2 hours, the Marines had advanced 400 yards beyond their previous positions and secured the high ground overlooking the island's central airfield. The breakthrough allowed evacuation of 23 wounded Marines who had been pinned down by machine gun fire. Medical personnel estimated that at least 200 Marines had been saved from potential casualties during the extended firefight that would have been necessary to reduce the Japanese positions through conventional tactics. The regimental commander, Colonel Samuel Morrison, arrived at Rodriguez's kitchen position at 14:30 hours to investigate reports of an unauthorized flamethrower attack. Morrison expected to find a cook who had improvised some kind of Molotov cocktail system. Instead, he found sophisticated engineering that demonstrated advanced understanding of pressure systems, fuel mixtures, and combustion dynamics. Morrison examined Rodriguez's improvised weapon and recognized that it represented innovation that could be replicated and improved for wider use. Morrison immediately classified Rodriguez's flamethrower design and ordered the regimental intelligence officer to document the complete technical specifications. The design was forwarded to Marine Corps headquarters for evaluation by weapons development personnel. Morrison also recommended Rodriguez for immediate transfer to combat engineering duties and promotion to sergeant. However, Rodriguez declined the transfer. He preferred to remain with his kitchen unit and continue feeding Marines. Morrison approved this decision but authorized Rodriguez to construct additional improvised flamethrowers for defensive use around the regimental command post. Rodriguez built 4 more flamethrower systems over the next week, using equipment salvaged from damaged vehicles, destroyed field kitchens, and abandoned Japanese positions. Each system incorporated significant improvements based on lessons learned from combat use and detailed analysis of the original design's performance characteristics. The second generation systems featured longer fuel lines constructed from aircraft hydraulic tubing salvaged from crashed F-4U Corsairs. The aircraft tubing was designed to handle higher pressures and provided better protection against shrapnel damage. Rodriguez increased fuel line length from 8 feet to 12 feet, allowing operators to maintain greater distance from targets while retaining effective flame projection. The additional length also provided tactical flexibility in choosing firing positions. Rodriguez improved the mixing chambers by using larger steel containers salvaged from destroyed ammunition storage boxes. The original mixing chamber had created turbulent fuel flow that reduced range and accuracy. The larger chambers allowed proper mixing of propane and compressed air before combustion, resulting in more stable flame streams with 15% greater effective range. The improved systems could engage targets effectively at distances up to 45 feet under favorable wind conditions. The ignition systems received the most significant upgrades. Rodriguez replaced the alcohol-soaked rag assembly with spark plug igniters salvaged from vehicle engines. The spark plugs provided reliable ignition without the fire hazard associated with open flames during system preparation. Rodriguez connected the spark plugs to portable battery packs, allowing remote ignition from protected positions. This eliminated the most dangerous phase of flamethrower operation when operators were most vulnerable to enemy fire. Safety improvements included pressure relief valves, constructed from truck tire valve stems, automatically venting excess pressure if the system exceeded safe operating parameters. Rodriguez added manual shutoff valves at multiple points in the fuel delivery system, allowing operators to isolate damaged sections without losing entire fuel supplies. He also developed standardized connection fittings using threaded pipe components, making field repairs and component replacement much faster. Rodriguez trained 12 Marines in the operation and maintenance of these systems, creating an informal flamethrower section that operated independently of standard military command structures. The training program covered technical operation, tactical employment, safety procedures, field maintenance, and emergency repair techniques. Each operator learned to construct improvised components from available materials, ensuring operational continuity even when standardized parts were unavailable. The training program emphasized safety protocols that Rodriguez had developed through trial and error during his initial construction efforts. Operators learned to test all connections under pressure before loading fuel, to maintain minimum safe distances from ignition sources, and to position escape routes before engaging targets. Rodriguez documented several near accidents that had occurred during his own learning process, using these examples to teach critical safety practices. Tactical training covered approach techniques adapted from standard military flamethrower doctrine, but modified for the characteristics of improvised systems. Rodriguez taught operators to coordinate with infantry support, to select firing positions with adequate concealment and withdrawal routes, and to engage targets in sequence to minimize exposure time. The improvised systems required different tactical approaches because of their unique capabilities and limitations. The flamethrower section proved highly effective against Japanese bunker positions throughout the remainder of the Iwo Jima campaign. Official records credit the section with neutralizing 23 fortified positions, eliminating an estimated 67 Japanese defenders, and destroying significant quantities of enemy equipment and supplies. More importantly, the rapid neutralization of defensive positions reduced American casualties by allowing infantry assaults to proceed without prolonged fighting. The psychological impact extended beyond immediate tactical results. Japanese defenders learned to expect flamethrower attacks from unexpected directions using non-standard equipment. This uncertainty forced them to modify defensive preparations and allocate resources to counter threats that might not materialize. The mere possibility of improvised flamethrower attacks created psychological pressure that affected Japanese defensive planning and troop morale. Rodriguez's innovation also influenced American tactical thinking about improvised weapons and field expedient solutions. Marine Corps observers documented his construction techniques and tactical employment methods for potential use in future operations. The documentation included detailed technical drawings, parts lists, construction procedures, and lessons learned from combat use. This information was distributed to other units facing similar tactical challenges. However, the improvised flamethrowers were never adopted as standard Marine Corps equipment. Despite their demonstrated effectiveness, official weapons development proceeded through established channels, with formal testing and evaluation procedures that emphasized standardized manufacturing, quality control, and safety certification. Rodriguez's field expedient designs were considered too dangerous for widespread use due to lack of safety features, non-standard components, and reliance on operator expertise for safe operation. The weapons development bureaucracy preferred systems that could be mass-produced with consistent specifications and operated safely by personnel with minimal specialized training. Rodriguez's flamethrowers required individual fabrication by skilled technicians and extensive operator training to achieve safe and effective employment. These characteristics made them unsuitable for large-scale military adoption, despite their tactical advantages in specific situations. Rodriguez survived the war and returned to El Paso in November 1945. He used his GI Bill benefits to attend engineering school and eventually established a successful restaurant equipment business. He never spoke publicly about his improvised flamethrower or the events on Iwo Jima. When local reporters attempted to interview him about his war service, Rodriguez insisted that he had simply been a cook who helped feed Marines. The real heroes, he said, were the men who fought and died on the black sand beaches. Rodriguez died in 1998 at the age of 79. His obituary in the El Paso Times mentioned his war service briefly and focused primarily on his contributions to the local restaurant industry and community organizations. The improvised flamethrower was not mentioned. Most people who knew Rodriguez never learned that a cook with no combat training had once neutralized a fortified Japanese position and saved the lives of 200 Marines using kitchen equipment and mechanical ingenuity. The technical specifications for Rodriguez's improvised flamethrower remain classified in Marine Corps historical archives. Weapons historians occasionally reference the innovation as an example of field expedient engineering during World War II. But detailed analysis has never been published. The system represents a forgotten chapter in the development of military flamethrower technology and the resourcefulness of American servicemen under extreme combat conditions. Rodriguez's story illustrates the difference between official military roles and actual combat contributions during the Pacific War. The Marine Corps initially viewed him as a support soldier whose primary value was preparing meals and maintaining morale through adequate food service. The military personnel system had classified Rodriguez as non-essential personnel, whose skills were not considered relevant to combat operations. This classification reflected the rigid specialization that characterized American military organization during World War II combat, revealed different capabilities that had not been recognized or utilized through normal military assignment procedures. Rodriguez possessed mechanical and engineering skills acquired through civilian work experience that proved more valuable than anyone realized until desperate circumstances required innovative solutions. His understanding of pressure systems, fuel handling, and combustion dynamics enabled him to solve tactical problems that conventional weapons could not address effectively. The technical challenges Rodriguez overcame were more complex than they initially appeared. Creating effective fuel, air mixtures required precise understanding of combustion chemistry and fluid dynamics. The propane-compressed air combination had to achieve proper stoichiometric ratios for complete combustion while maintaining sufficient energy density for weapons applications. Too much air produced weak flames with insufficient heat. Too little air created fuel, rich combustion with excessive smoke that revealed operator positions. Rodriguez's pressure chamber design solved these problems through empirical testing and iterative improvement. The mixing chamber volume had to be large enough to allow proper fuel, air blending but small enough to maintain pressure differential for effective projection. The internal baffles Rodriguez constructed from bent metal plates created turbulent mixing that improved combustion efficiency while preventing backfire propagation to the fuel tanks. The ignition timing system represented perhaps his most sophisticated technical innovation. Standard military flamethrowers used continuous pilot flames that created operational security risks and fuel consumption problems. Rodriguez developed a delayed ignition system that allowed fuel-air mixture to establish proper concentration before spark ignition occurred. This technique improved flame stability and reduced the likelihood of combustion failure during critical moments. Rodriguez developed specialized ammunition loading procedures that maximized the effectiveness of his improvised systems while maintaining safety margins. He discovered that propane combustion efficiency increased significantly when the fuel was preheated before entering the mixing chamber. Rodriguez used exhaust heat from the compressed air system to warm the propane lines, increasing fuel vaporization rates and improving combustion characteristics. The preheating system consisted of copper tubing coils wrapped around the compressed air exhaust ports. Propane flowing through these coils reached approximately 80 degrees Fahrenheit before mixing with compressed air, compared to 45 degrees for unheated fuel. The temperature difference improved fuel atomization and created more stable flame streams with 20% greater range and significantly reduced smoke production. Rodriguez also developed specialized fuel mixtures by combining propane with other combustible materials available from kitchen and vehicle maintenance supplies. Adding small quantities of gasoline to the propane supply created flames that adhered better to target surfaces and burned longer after initial impact. The gasoline-propane mixture was more dangerous to handle but provided superior anti-personnel effectiveness against bunker positions with multiple occupants. Experimental mixtures using alcohol, cooking oil, and soap created thickened fuels that functioned similarly to military napalm. These mixtures burned at lower temperatures than pure propane, but maintained combustion for longer periods, making them effective against equipment and supplies rather than personnel. Rodriguez found that thickened fuels worked best for destroying ammunition storage areas and communication equipment inside bunker complexes. The most advanced system Rodriguez developed used multiple fuel supplies simultaneously. 2 propane tanks provided primary combustion fuel, while a separate container supplied thickening agents and flame adherence compounds. The operator could select fuel types depending on target characteristics and tactical requirements. Anti-personnel attacks used pure propane for maximum temperature. Anti-material attacks used thickened mixtures for sustained burning. This multi-fuel system required complex valve arrangements and precise timing to prevent dangerous fuel interactions within the delivery system. Rodriguez spent considerable time developing safe operating procedures and emergency shutdown protocols. The complexity made these systems unsuitable for general use, but experienced operators achieved remarkable tactical effectiveness against specific target types. The psychological impact of Rodriguez's flamethrower innovations extended beyond their immediate tactical effects on Iwo Jima. Word of the improvised weapon spread through Pacific theater units, inspiring similar innovations using locally available materials. Marine and Army units began experimenting with field expedient flamethrower construction, using different base materials and techniques adapted to their specific operational environments. These derivative systems rarely achieved the sophistication of Rodriguez's original designs, but they demonstrated the broader principle that innovative soldiers could create effective weapons from unconventional materials when operational necessity demanded creative solutions. The psychological effect on American forces was significant. Units that had felt helpless against fortified Japanese positions gained confidence from knowing that determined individuals could develop countermeasures using ingenuity and available resources. Japanese forces also adapted their defensive preparations in response to the threat of improvised American flamethrower attacks. Intelligence reports from captured positions revealed that Japanese commanders issued specific instructions for countering non-standard incendiary weapons. These countermeasures included improved ventilation systems in bunkers, additional fire suppression equipment, and modified defensive positions designed to reduce vulnerability to flame attacks from unexpected directions. The Japanese adaptations reduced the effectiveness of subsequent improvised flamethrower attacks as the war progressed, but they also forced Japanese units to divert resources and attention from other defensive priorities. The mere possibility of facing innovative American weapons created planning complications and resource allocation problems that contributed to overall Japanese defensive degradation throughout the Pacific Campaign. The broader lesson extends beyond individual heroism to organizational adaptation. Military units that encourage initiative and creative problem solving tend to discover hidden capabilities among their personnel. Rodriguez was not unique in possessing technical skills that could be applied to combat problems. He was unique in being given the opportunity and freedom to apply those skills when conventional solutions had failed. His success demonstrated the value of allowing soldiers to contribute beyond their assigned specialties when tactical situations demand innovative approaches. Rodriguez's improvised flamethrower saved 200 Marines, not through superior firepower, but through the psychological effect of introducing an unexpected weapon system that Japanese defenders had not encountered before. The tactical surprise was as important as the physical damage inflicted. This principle applies to many successful military innovations throughout history. Sometimes the most effective weapon is one the enemy cannot predict or counter because it falls outside established tactical doctrine. The cook who built a flamethrower from kitchen parts became a sergeant who continued cooking for Marines. Rodriguez understood that feeding soldiers was as important as fighting enemies. Both missions required the same attention to detail, the same commitment to excellence, and the same willingness to innovate when standard procedures proved inadequate. His greatest achievement was not the technical innovation itself, but the recognition that every role in military operations contributes to mission success when performed with competence and dedication. If this story moved you, please like and subscribe. Your support helps us preserve these histories. Tell us in the comments where you are watching from. We honor the courage and ingenuity of these men by remembering their names.